All right, Maddie, let's try this with the calculator. These are the calculator questions, number 9, 10, 11, and 12. Uses the same two functions, 1 minus x squared and x to the fourth minus x to the, x to the sixth. X to the 6 minus x plus 1. So let me fix that. Okay, so the first question asks you for the point of intersection for these two functions, right? And so algebraically, we did that by setting the two equations equal to each other and solving. This is a lot harder to solve by hand though, so that's why your teacher allowed you to use the calculator. So what I did is I put the first function in my y1, the second function in my y2, and then when you go to graph it, that's your first function, the parabola, and then you have your second function. So it looks like they intersect here somewhere, right? And so I want to kind of zoom in a little bit to see that better. So I'm going to go to zoom, and I'm going to go to number 2, zoom in, and then I'm just going to push enter and zoom it in. So again, there's my parabola, and then there's my x to the 6th graph. So it looks like my parabola is on the top every single time, that whole time, the area in between, right? And so we want to figure out the two intersection points. It looks like there's one here and there's one here. So your calculator will actually do all of that for you. You're going to go second, you're going to go calculate or trace, and we're going to go down to intersect. Mine's number 5. It's going to ask you for a first curve, so I'm just going to scroll over and say that this is my first curve, and I'm going to push enter. And then it jumps up to that second curve, and I'm going to push enter. And then I'm going to push enter again when it asks me to guess. And you can see on this x value, it's e to the negative 13. That's kind of like a scientific notation. If you had 4.682 times 10 to the negative 13, you'd move your decimal place over to the left 13 times, which is a really small number. What your calculator is saying is it's really close to 0. So 0, 1 would be the intersection there. So x equals 0. And then you do it again to find that other intersection point. So second trace, intersect. And I'm going to go a little bit closer to this intersection now so it knows to find that one. If you stay too close to the other one, it's going to keep finding that 0. When it asks me for first curve, I'm going to push enter. It's going to jump down to that second curve, hopefully. I'm going to push enter, and then I'm going to push enter again at my guess. And so it looks like there's another intersection there. You can write down both the x and the y, and I think your teacher even said to 6 decimal places, so make sure that you round it to the 6 decimal places. And then we're going to be using those numbers later on when we do area and volume, so make sure that you write those down. Okay, so we have our two x coordinates of our intersection, point of intersection, 0 and 0.754878. Okay, number 10 says find the area of that region. So we want to figure out what the area of this little region between the two curves is. Remember, when we find the area in between two curves, we have to find their intersection, which we just did. We have to figure out which function is on the top versus the bottom. And since we can just see on the calculator that the parabola is on the top and the x to the 6th graph is on the bottom, we already know which one's our top and our bottom. And so now we can just set up our integral. We're going to integrate it from 0 to 0.754878 of top minus bottom. And so your equation should look something like that. You can even put that in your calculator and have it calculate for you. Another way you can do it, let's see if this works. We already have our two functions in there. One is my y1 and one is my y2. And remember, my y1 is my parabola, and that's the top function. This is my bottom function. So what I can actually try to do here is in my y3, I'm going to do vars. I'm going to go y vars. I'm going to select function. I'm going to select y1 minus, and then I'm going to do y2 that same way. Vars, y vars, function, y2. So in my y3, I have whatever's in my y1 minus whatever's in my y2. Instead of retyping it all out to subtract the two functions, I can just actually do it in my calculator. I'm going to unselect those other two. Do you see how the y3 is the only one with the equal to sign highlighted? what I did is I went over the top of the equal to sign and pushed enter. So that way my y1 and my y2 are still programmed to my calculator, but I'm only working with the y3. That's the two functions being subtracted. Because really what I want to do is I want to integrate this guy, the y1 minus y2. I'm going to go second, trace. I'm going to go down to number 7. That's the integration one. I'm going to integrate that function. That's why it was important to turn off the 1 and 2 and just look at the 3. If you didn't turn off the 1 and 2, it would just integrate that first one. It wants us to pick the lower limit and upper limit. Remember, the lower limit and upper limit are the two intersections. So the first intersection was 0. The second intersection was the 0.754878. And I'm going to push enter. You see how it shades it for you? We're finding the area in between those two curves. So this function represents the two curves being subtracted, and we're finding the area from 0 to 0.75, whatever. And so you can see that the area in between those two curves is the 0.122, all using my calculator. I would definitely write all of your setup though on your paper so that if you make a mistake somehow, hopefully you still get partial credit for the other pieces. Okay, so the next question, I'm going to turn those back on and turn Y3 off. So my next question says, what is the volume generated when that area is rotated about the x-axis? Well, if the x-axis is this way, and I want to stack my rectangles along the x, it looks like those two are perpendicular, right? And so I'm going to use disk or washer method. If I'm looking at the graph again of those two original functions, and I'm thinking about this area as the shaded area, and I go and I start to rotate that shaded area along the x, isn't there a gap in between here? And so there's going to be a washer method, there's going to be a hole here, and then there's going to be that shaded area that's being rotated around. So this is, instead of a disk method, is actually a washer method because there's the hole. So I want to then do the integration from 0 to the 0.75 of pi big R squared minus pi little r squared. I can take the pi out in front, I can integrate still from 0 to the 0.75, and then I need to figure out what my big radius is minus my small radius. Remember, your radius is from the axis of revolution all the way to the top is your big radius, and then your axis of revolution to the bottom. So it looks like my big radius is the one that corresponds to that parabola, the 1 minus x squared, and then my little radius is the one that corresponds to that x to the 6th graph. So your setup on this one should look something like this. I have my pi, I'm going to integrate it from 0 to that 0.75, my big R squared minus my little r squared, and then it'll give me the answer. Now again, this is my y1 squared minus my y2 squared. So I can still do that in my calculator. I just have to, I'm going to go ahead and just clear this out. I'm going to go, let's see if this works. Vars, y1, and let's square it, minus my vars, y2, and I want to square it. So that's y1 minus y1 squared minus y2 squared, right? Isn't that what I want? Let's make sure I turn off my other two, so that one's the only one that's being shown. So that's my big R squared minus my little r squared, and I want to integrate it. So second trace, I'm going to go down to number 7 and integrate. I'm going to pick my lower limit and my upper limit. My lower limit was 0. My upper limit was 0.754878. So that's my answer of my integral. But remember, I still want to take that and multiply it by pi. So since it's already programmed in my calculator, I'm just going to go second, quit, go back to my regular calculator screen, and I'm going to multiply that answer by pi. And I get my 0.544, which is the correct answer, all using my calculator. Okay, the next one is, let's turn these back on, is rotating around the y-axis. So if I look at my picture of my two original graphs again, I think about that little area that's in between those two, this little area right here, and I think about rotating around the y-axis. So here's my y-axis, and my rectangles are again stacked along the x. So my axis of revolution and my rectangles are parallel. If they're parallel, then that means I'm going to do the shell method. I want to do 2 pi ph, right? My limits of integration still are from 0 to the 0.75, the intersection, 0 to the 0.75. I have my 2 pi out in front. Now I want to figure out my p and my h. Remember, my p is the distance from the axis of revolution to any one of those rectangles. So it looks like that corresponds to the x value. And then I want to figure out the height of all these little rectangles inside here. That looks like it's the top minus bottom, the difference between the two functions. So that's my top minus bottom. Okay, so you might have to do a little bit more on this one, writing it out and getting yourself a new function, putting it into your y equals. But this is what the setup looks like. If I were you, I would probably, I guess you could program this in your calculator and say that this is y2 minus y1 times another x if you wanted to. That should work. Integrate it from 0 to 0.754878, and then take that answer and multiply it by 2 pi. You should get 0.308. Or you can just do it by hand, distribute the x, and put that new function in your calculator and evaluate. Just don't forget to multiply by the 2 pi when you're done. Now, number 13, we can find the average value pretty easily, integrating from 0 to 10 of your function, and then don't forget to divide by 5. I just don't remember how to find this mean value part, so you'll probably have to ask your teacher about that piece. But the average value is pretty simple. You just put this in your calculator into your y1, integrate it, second trace, that's number 7, your lower limit is 5, your upper limit is 10, get an answer, and then divide it by 5. Okay, so hopefully that one works out. I'm going to show you number 15, and then I'll go back and look at number 14 probably in a different video. Number 15 asks you to find the area of the region bounded by the two curves. So this isn't a volume, this is just an area one. And so we need to first figure out what our limits of integration are going to be. So what I would probably do is put these two functions into your y1 and your y2. That's x divided by, and in parentheses, I'm going to do the square root of x squared plus 1, parentheses, parentheses. That's my first function. My second function is x to the 4th minus x. I'm going to find their intersection, so second trace intersection. And then I'm going to follow what we did to find the intersection before. So there's our area between the two curves, and we want to find that area. It looks like the top function was the first one, so now we know what the top one is, and then the bottom one is, because eventually we're going to have to integrate top minus bottom. But we don't know where to start and where to end, what our limits of integration is. That's why we need to find these two intersection points, right? So intersection, my first curve, let's make sure that I'm on that first curve. That's the top one. Push enter. It looks like I'm on the bottom curve now. Push enter again, and it looks like my intersection is at 0. Do it again for your other intersection. Go closer to that other intersection so it doesn't go back to 0. First curve, second curve, and then it looks like my intersection is 1.1807776. So make sure you're going out to probably 6 decimal places like your teacher asked. So now that I have my limits of integration, 0 and the 1.18, I can integrate this top minus bottom. That's my y1 minus my y2. I can turn those off. I can go down to my y3. I can go vars, y vars, function, y1 minus vars, y vars, function, y2, so I don't have to type the whole thing in again. I've got my top minus my bottom. That's the only one that's highlighted. I'm going to integrate it. I know my limits of integration from my intersections that we just found. 0 and 1.180776. And I can find the area between those two curves, 0.785. All right, hopefully that helps. And then I'll show you number 14. That one is a little trickier. I would like to show you that by hand, and then you could probably figure out how to put it in your calculator to evaluate it. But I wanted to show you the kind of the picture and how you do it by hand in another video.